Evan's math lesson.
That sounds fantastic. I say I'll do a little bit of math, and then we'll open the floor to questions about art of problem solving and stuff like that. That sound reasonable?
Cool.
All right, awesome. So I've got a little bit of math prepared for you guys. I'm going to share my screen now, and just to warn you, I noticed during this call, at first I thought there was about 20 students in here, because I see 4 rows of 5 on my screen, and then I realized that this says this is page 1 of 7. So there are a lot more of you than I realized, and I haven't dealt with a Zoom class of quite so many. I think there's actually about 150 of you, maybe, based on that estimate. So we will see how it goes. So I'm gonna share screen now. Okay. So we should have our first problem here. I brought just a couple for you guys. So here's my first question to you, and I need you guys to be active participants, because like I said, doing math is a very active pursuit, and I think the way you're going to learn best in general, and this sort of art of problem solving philosophy as well, which I'm going to be interleaving in through this math, is that you really need to learn by doing, sort of by doing the thinking yourself and by trying to figure things out. That's the best way to get better at problem solving and at math. And sort of at problem solving is the core of what we really care about, honestly. Most small math facts, they're interesting sometimes, and they're probably sometimes useful, but memorizing and remembering those is not what our problem solving is about. What our problem solving is about is figuring out how to solve problems, how to solve new problems that you don't know how to do yet. That is what I try to teach students. So without further ado, I kind of want to hear from the students. What is your first thought when you see a problem like this? Anybody can maybe send a chat or raise your hand, or okay, some people are yelling out some thoughts on answers. What I want to hear actually is not an answer, but what is your first thought? Like, how do you approach this? How did you try to figure that out? So I've got a raised hand from Mod 4, looks like people are saying. Mod 6, what do you mean by that? There's find a pattern. Okay, I like this. Dia, I really like what Dia said here. Finding a pattern, right? So this is a big, important strategy here. It's like, okay, I see this and I see 13, right? That's really small, but 100 is what we're looking for. That's a big number. I don't want to draw this out to 100, right? So what can I try to do? And Dia said, hey, look for a pattern, right? And that's actually often really useful, is to look for patterns in these things when you're dealing with big numbers. So what kind of patterns do you guys notice? Does anybody point out a pattern that they see? The pattern repeats every 4 numbers. Okay, right? I see a couple of things like that. So these things have gaps of 4, right? Plus 4. That's an interesting pattern. What else do you guys see? Oh, that's interesting. Multiples of 4 on the bottom row. Oh, okay. Right. So all of these guys are multiples of 4. Okay, that's interesting. Yeah, from Trisant there saying, okay, well, we know 100 is a multiple of 4, right? So 100 is going to be on the bottom row. Okay, that's interesting to us. So it's just going to put you a 100 down here. Okay, and somebody else noticed another interesting pattern, by the way. That's middle number is all the odd numbers, right? So here are all the odds. Maybe I should color those in a different color, actually. Let me grab a different pen. Orange for odd. They both start with O. Orange. Ends with an E. Orange. Why am I writing orange? I'm supposed to be writing odd. But anyway, the middle row is all the odds. All right, so we've got the odds in the middle, plus 4 on the top, and multiples of 4 on the bottom. Okay, that's really interesting. So now, how can we use that to try to solve this problem? So 100's on the bottom row. What does that tell us? Right, so what number is going to be directly west of 100 based on this? Right, it's going to be 96, because it's going to be exactly 100 minus 4. I saw somebody write in there. That's really interesting. So if we want to go backward by 1 stop here on the bottom row, we subtract 4, right? Because to get to the next lower multiple of 4, we subtract 4. So 100 is going to go over here to 96, right? And so there's our answer. It's 96. And so there's really one thing I want to point out here is a couple of different things in this problem solving is, number one, I think a really, really important tactic is to try to look for patterns. Try smaller examples, right? So here we're basically generalizing from looking at this pattern on just this grid of 13 numbers. And we're trying to generalize and say, oh, look, all these multiples of 4 on the bottom. And so making observations from trying small cases is a really, really important problem solving strategy. And then trying to generalize this to find patterns, very important. And a couple of other strategies that we used here that I think are important and subtle and something that people don't necessarily think about as, problem solving strategies are important math strategies, but we were drawing pictures. We were labeling things. And I think those are really important. That's something that I really like to emphasize here. Draw a picture, try to make things as clear as you can to yourself, do some organizational techniques, right? Whatever you can. I think that's really important. So what I'm going to do now is go ahead and jump onto another problem, which is very similar, but here we've got a slightly more complicated looking pattern for the train stations. Okay, so Beast Island is a little more complicated than Cyclops City. So here's what I want to do is figure out, hey, okay, which stop is directly to the east of stop 150 on Beast Island? Okay, so based on what we did before, what do you guys think a good strategy is going to be here? Yeah, find a pattern. I love that. Exactly. We're going to try to look for a pattern. Okay, so what kind of pattern are you guys seeing? Or how can we even start to look for a pattern? How about this? Just before we even do that, I think it's useful to try to get an example of, hey, what's going on? How can we figure out what's going on here? So can you tell me what stop is directly to the east of 7? Right, directly to the east of 7 here, it's 14. So we go directly east. Okay, so we want to find what's directly east of 150. So looking at these small numbers can get us some kind of ideas. I really like your ideas of looking for patterns. I think that's sort of the key idea that we had before. So does anybody notice any patterns? Oh, that's really interesting. I noticed there somebody saying, look at the corners, right? The corners they're probably really crucial points on this graph. Like that's what I like to think about. Okay, where am I, if I'm gonna look for a pattern, where's an interesting place to look? The corners is definitely interesting. What do you notice about the corners? Right, the corners are all multiples of 3. Okay, so let's go ahead and put that in. I think multiples of 3 like to be purple. So this is all multiples of 3. Yeah, I noticed that as well. Okay, how does that help us? That those are all multiples of 3. Right, 150 should appear at a corner. Exactly, I see that in the chat. So 150 is a multiple of 3. So 150 is going to be at a corner. Oh, so this should be really easy, right? I can just generalize from here. I'm at a corner. I go plus 1. So it should be 151, right? Do you guys all agree with that? Oh, right. I see somebody said the unconnected corners, they differ by 9. Plus 9. So we'd have to figure out what kind of corner are we on here? Okay, how are we going to do that? Anybody have any thoughts there? Okay, somebody said divide it by 12. That's really interesting, actually, because we can see this pattern kind of repeats in blocks of 12. I like that idea. I'm going to just grab a block of 12 just to kind of point out what they're saying there. So yeah, block of 12, this pattern is going to repeat again in another block of 12, which I find very interesting. That's certainly one kind of tactic we can do, although I circled 13, but you get the idea. There's another interesting I saw. There are corners which are open are multiples of 6. That's really interesting. If we grab all the multiples of 6, look at what we're noticing here. The multiples of 6, but the multiples of 6 actually always have a gap to the right of them. That's a really interesting pattern. Does that tell us anything interesting? Right, exactly. 150 is going to be is a multiple of 6, right? It's even and it's a multiple of 3. So it's going to be at one of these gap corners, okay? So 150, that's what we've discovered from looking through all these patterns, is that 150 is at a gap corner. So with that discovery, what can we say is the answer to this problem? Yeah, exactly. We just add 9. I love that observation, right? Like, well, that's easy. We just add 9 now. It's 159. So the key idea here again was looking for these patterns. And I noticed some of you also noticed a lot of other interesting patterns that we could say here, right? You guys are saying, oh, the even multiples of 6 are all on the bottom and the odd multiples of 6 are all on the top. That's really interesting. I really like that as well. I think there are lots of different patterns that you could notice. You don't have to just notice this one. This was just kind of the majority that I noticed from you guys. But there are lots of different things. Like I mentioned, this sort of repeating in blocks of 12 you could look at. Or you could look at, hey, I noticed odd multiples of 6 were on the top. And maybe 150 is one of those. So you could even know even more detail where 150 is. And this sort of repeating the 12 pattern can actually help you solve different problems as well. For example, if you wanted to know, hey, what's going to be just to the right of 147 or 148 maybe, that might be a little bit tougher because you'd have to figure out where it is on the graph. Is it on the top or on the side? But using this repeating by 12 pattern could help. You could also use multiple of 3 pattern. I encourage you to think about that problem later. Maybe you can generalize this to figure out what is directly to the east of a number based on some conditions and see what conditions you can find to try to help you figure that out. But again, you can kind of see what were the big problem solving strategies we threw at this problem. Does anybody have any sense here? I'm just letting people type in the chat if they have any thoughts on what strategies did we use to solve this problem. What was our sort of tactic? What takeaways should we have from this? Yeah, multiples. I really like that. We looked at multiples and remainders. I think that's another thing. Like these are both interesting, important problems, interesting ideas that came up in this, and that's exactly what we used. We looked for patterns. I think is also definitely a key skill. Yeah, multiples of 3. Yeah, we looked at sort of arithmetic regressions and things. We looked at these common differences, generalizations. I think that's really good. Yeah, repeating sequence. Yeah, exactly. We looked for something that repeats and sort of makes a sequence, right? Yeah, observation is key. I really love that, actually. This is all about making observations. That's a lot of what math is about. I'm going to play around and try to discover things and make observations and see what we can find. So yeah, I really like that. That's really good. So I have one last problem for you guys. This one's really, really tough that I don't necessarily expect you to solve. I want to just get a small taste of it and then let you guys think about it on your own later a little bit more. Just sort of a takeaway problem for you guys to have sort of at home later. Okay, so find all positive integers n so that a square can be dissected into n smaller squares. The side lengths of smaller squares can be equal or different. So here is an example of me dissecting a square into 42 smaller squares, which is perhaps not a useful pattern, but I really love just noticing some things here. Observe and generalizing is important. I really noticed somebody said simplifying a complex problem. Yeah, that is a really, really important problem solving strategy. Try to simplify a problem, right? This thing was going up to 150. We really simplified it into understanding just this small grid of 12. Okay, so I'm noticing something from you guys. Some people are saying interesting. Some people are saying perfect squares. That's really interesting. So that's one pattern that we can grab right away. Is hey, we can probably do perfect squares. And I love what people are saying here. We should try to construct some of these squares. That's really, really interesting. That's definitely the way I would go about solving this problem. Let's try to construct some of these and see what we can find. So I'm going to draw a picture for a perfect square since you guys mentioned that. So I'll draw just a couple of those. So we've got 4 here is pretty straightforward. There's breaking our square into 4 squares, right? And you mentioned we can do other perfect squares, which we could do in the same way. So here we can get 9, and we continue that. Do you guys think that's everything we can get? Is just the perfect squares? Oh, that's interesting. A number that can be expressed as sums of smaller squares. What do you mean by that? Different sizes. Interesting. Yeah, these squares don't have to all be the same size, right? This perfect square thing is really forcing us to use the exact same size, and we don't necessarily need to do that. So what else can we do? Some people are saying infinite solutions. I think that's certainly possible. Oh, a number that is the sum of n perfect squares. Yeah, there will be infinite solutions, by the way, to people asking. So we're trying to just describe them. So for example, the answer might be all even numbers or all perfect squares. Like those would be fine answers, and those are infinite. Those are infinite sets, and that's okay. So anything like that would totally be okay. Okay, so I really like something that people are saying here. People are saying that we can use a recurrence or writing things as the sums of squares. Can you people who are saying recurrence, tell me what you mean by that? What some of us might not know exactly what that fancy word means. Right, exactly. I really like what somebody said here. They're all squares, right? Once we've divided into perfect squares, hey, look what I noticed. I divided this thing into 4 squares, but here I've got a square, right? We've got the same problem here. That's what recurrence is when you realize, whoa, I could do the same problem again on a smaller square. So what can I divide this small square that I just circled into? Based on what we've done so far. I can divide it into 4. Yeah, I could totally do that, right? That's easy. I'll just do this. Okay. So what happened when I divided that small square into 4? Yeah, we can divide them continuously to keep getting squares of squares. Exactly. We can keep doing that. Yeah, I really like what people are noticing here is that we can sort of keep dividing it. We can divide it by another square. We could pick one of these really small ones here and say, hey, you know what? I want to go ahead and divide this little one into 4 squares, and we'll pretend I did that right. Right? Yeah, you can keep on doing that. Exactly. And what happens every time I do that? Every time I divide one square into 4, how does it change the total number of squares that I have? It increases. Yeah. By how much? Yeah, we add 3, right? Because we took one little square and turned it into 4 little squares. So we got rid of 1 and ended up with 4. So that's plus 3. So every time we do this, plus 3 every time. Okay, so that's really interesting. So what sort of class of numbers does that give us if we can add 3 over and over again to anything we have? So it looks sort of like it gives us multiples of 3. I like whoever said that. But we didn't start with 3, for example. We started with 4, right? Yeah, okay. So 4 plus a multiple of 3 is what I'm seeing here, right? So this gives us anything 4 plus multiple of 3. We can get all of those numbers, right? Right, and this is equivalent, like some of you guys are saying, using modular arithmetic, to numbers that are 1 mod 3. You don't need to know that fancy terms, but that is numbers who have a remainder of 1. Remainder of 1 divided by 3. We can get all of those. Okay, so my question to you that I want you to think about is that everything? Can we only get things that have a remainder of 1 when divided by 3, or could we get some with remainder of 2 or 0? Are either of those possible? Somebody's yelling no. I see it in all caps showing up on my chat. So that's very interesting. We can get 9. Actually, yeah, we've got 9 right here. It's already on the screen. 9 is on the screen. 9 is on the screen. So certainly we can't only get things that have a remainder of 1. Okay. So now, what does that 9 allow us to do? Yeah, somebody just said 0 mod is also possible. Yeah, that's interesting. We can add 8, someone said. So now we can add 8 or 3. And somebody says we can generalize using n squared, right? Because now we can take this, and what can I do with the little squares inside of this 9? Yeah, I can divide them into 4s if I wanted to. That's really interesting. So if I divided this into 4, now suddenly how many squares do I have in that bottom picture? Right, we suddenly have 13. 13, is that right? No, we have 12, right? Because we added 3. That's our sort of lesson. Whenever we break something in 4, we add 3. Okay, so here we've got 12. Okay, and if we kept doing this, what would we get? What would we get from doing that? Yeah, we'd get 9 plus a multiple of 3, right? So that's everything that has remainder 0 mod when divided by 3. That's bigger than 9. That's at least 9. So we'd get, 9, 12, 15, all the multiples of 3 that are at least 9 we would get. And I like some people had some other comments here. What happens if instead of breaking this into 4, what if I decided, you know what, I want to break this into 9? That was a really interesting comment from somebody there. What happens if you break that into 9? What do you end up with there? We end up with 17. Yeah, or we can keep going here, and some people are generalizing and saying we'll get anything of the form 9 plus 8n. That's really interesting. So there are lots of different numbers that we're getting here, and one thing I want to point out is my work is getting kind of messy. I've noticed I'm writing lots of things on the board. It's going crazy. I'm not even sure all the types of numbers we can get, right? So another important problem-solving strategy I want to impart on you that's sort of taught by this messiness here is it's really useful to try to organize and keep track of what you have. Maybe make a table or something, right? So we might want to make a table of the types of numbers we can get, or have somewhere where we have all of our information clear, okay? And what I want to do is, I think we've done enough of this. I want to leave the rest of this problem to you guys. I want you guys to think about this on your own, try to solve it later, and see if you can find all the numbers we can get. There are some tricky ones, and in particular, some tricky small numbers that we haven't really thought about. For example, can you get 6? That's an interesting question. We just said we can get all the multiples of 3, but they needed to be above 9, right? Can we do 6? That's an interesting question, right? So I really want you guys to think about that on your own later. And I think this is a great problem to take away and think about and sort of try on your own. So from there, I'm gonna be stopping my math lesson. Thank you all for participating in that. I think I had a really good time. Actually, the chat worked really well. You guys were excellent participants and really good at throwing out ideas into the chat, which I think is really, really important. Throwing out these ideas is really the way you're going to learn, and the way art of problem solving really tries to emphasize is everyone should be, shouting out their ideas and trying to figure out whatever they can. So, and I really love the enthusiasm for the math. You guys are all awesome. Thank you so much. So I will turn back over to Grayson here. I can leave the problem up on the screen if you guys want it there, so you can think about it on your own. But I think Grayson's got perhaps a little bit more, and we'll take questions about art of problem solving. Or maybe Vinay has something to say here. I'm not sure. His video just came on.
No, you please complete if you had to say something.
No, I'm good.
All you, Vinay.
Yeah, hi, Grayson. So thanks a lot, Devin. I mean, this was I think that the kids loved this session the most. I can say the way they all have responded in the chat, and there is nothing like getting to work on a problem, right?
Yeah, I had a great time with you guys, with all of you students. It was fantastic.
Thank you. So would you guys want to take questions now?
I am happy to take questions. Unless Grayson has some more to talk about first. Grayson?
Grayson?
I think Grayson might be lagging, it looks like. Okay. Oh, Grayson, did you just show up again?
Vinay, would you like to invite some of the students who've taken AoPS courses?
Yeah, I can do that. So a few of our participants, Devin, have taken AoPS courses, or they have gone through AoPS material. So would you like them to share some of their experience in the interest of everyone?
I'd love to hear that. Yeah, and okay. I think that'd be really interesting to hear what people are thinking. And by the way, I think a lot of you guys have been saying that you really enjoyed the math in the sessions. Thank you so much. I really appreciate that. But yeah, if anybody has anything they want to share about art problem solving, their own experience, I'd love to hear it.
Okay, so I'm just calling out some names of the people who have taken AoPS courses. And if you'd like to share your experience of how you have felt about AoPS, then please unmute yourself or just raise hand. Okay, that's Naren. Naren has done. Yes, Naren.
Yes, sir. So I really like the way AOPS teaches you. So instead of making you think like in a procedural way, yeah, it it teaches you multiple different ways of approaching a problem. You really understand the concept at its root, so you can manipulate it however you want to solve the problem. The problems are never direct. Like you always have to think about how to approach the problem to actually solve it. Like you can always think creatively. Um, like I find AOPS is a platform for like creative thinking, and even the books teach you concepts from like the roots, and you really understand how they work.
Okay, thank you, Naren.
Thank you. Thank you.
Yeah, that was great. I actually noticed a few of you mentioning the time of art of problem solving class as being perhaps a little bit difficult. So I'm wondering, just as a question from me, that it might be something that leads to something. If we can, what timing would be more ideal for you guys? Is it too early? Is it would it earlier in the day for us be better? Later in the day? What is it there?
Sorry, can you just repeat the question?
I'm just kind of curious. I noticed a few people in
What
the
time
chat.
of the day will be?
Yeah. So would it be better if
sorry.
we move to them earlier in the day for us? So right now they're at 4:30 Pacific time. So earlier better. 5 in the morning is the class time. So later would be better. Okay. Earlier would not be better. Yeah. Okay. That's really interesting. So later classes would help. That's interesting to know. I can't make any promises, but that's really interesting to know. It's interesting data to have, that the timing is sort of a restricting factor for some people.
There are a couple of more participants. I mean, students who have taken AoPS, and they were saying that they want to say something. So
yep.
I'm just going to
please
quickly unmute them. Yeah, Avni.
Yes, sir.
Yes, Avni.
Yeah. So I'm. My name is Avni, and I'm very enthusiastic about like higher level math. So like I've tried studying from books, but like at times it's like some books start from a very high level, and sometimes like either you get questions that are too easy for you or that are too difficult for you. So yeah. So then I like I read that some people had mentioned ki okay, AoPS really helped me. So yeah, I went over to that site, and so pehle I had to search around a bit, but then like I found Alchemist on that, and yeah, I found that, and then like it was like pretty systematic. Like you can check exactly which concept you want to work on, like, so that's really helpful.
That's awesome. Yeah, thank you. And some people, I just noticed in the chat, somebody asking, "What is Alchemist?" You could answer that if you want, Ani, or I can.
Yeah. Go
yeah,
for it.
Also, can you explain a bit about the classes? Because like I visited the site, but like I could not understand like how the classes are gonna work.
Okay, yeah, I'll give you some ideas. So first, to answer the people what is Alchemist? Alchemist is our adaptive learning system. So what that does is basically it gives you problems and tries to meet your level. So if you're, crushing the problems, getting them all right, it's going to give you more challenging ones and it's trying to meet everyone at the right level of challenge. Because just like Avani was saying, you want problems that are just enough to be a tough challenge for you. You don't want to solve them easily, but you don't want them to be, hey, so far off that I just can't even fathom figuring out this problem. And that's where you're going to learn the most. So that's what Alchemist really tries to do. It tries to meet you at your level. So that's it's free. It's an adaptive tool. Anyone can go. It's just register for art of problem solving. Go to Alchemist. Anyone can play. You can choose your subject you want to study, whatever it is. And it's just a huge bank of problems. There's over 13,000 problems in Alchemist, spanning from subjects pre-algebra through pre-calculus. that you can jump in, and it'll like I said, it's sort of any individual topic that you jump in, it tries to adapt to you and give you either harder or easier problem.
And then real quick, so we actually, for those of you that might be wondering beyond what it is, if you want to get a little bit more information about what it is and why we called it that, we even wrote an article about Alchemist, and I just posted it to the group chat here, so everyone can take some time to read that later on. Devin, you can go back into the spiel about the classes.
The other thing I was going to say was, you guys were asking about, hey, what are art of problem solving classes like? I actually want to say they're a lot like what we were just doing here. So we're not on video, but the way you guys were all interacting with me was through this chat, right? You guys were all throwing out ideas through this chat room. And that's basically exactly what art of problem solving classes work like. We're always solving problems. So like you noticed here, when I'm sharing my screen, all I had was problems for you guys. I'm not giving you guys, hey, here's a bunch of definitions, here's a bunch of facts, remember these. And, we're kind of just always solving problems. And, definitions of fact, they're going to come up while we're working through these things, but we're always trying to solve problems and figure things out. And so the way the art of problem solving classes work is we try to solve these as a group. We say, okay, here's the problem. What are your guys' ideas? We're going to do that through text chat, and you guys will be throwing out all of your ideas through text, and kind of the teacher then brings, so all of those things go directly to the teacher. And the teacher then puts some of them in the main room to kind of build this narrative of the whole group together solving problems. And through that, we try to figure out new math concepts and basically just improve our problem solving skills. And there are a few teaching assistants in the room as well. So today you only had me, unfortunately, but in a regular art of problem solving classroom, you'd have me and 2 other assistants who are there to help people individually if they have questions or things like that. So that's kind of the general way art of problem solving classes work. Is a lot like this session I did today.
Okay, thank you, Devin. One more question, maybe. One more comment kind of thing. Sri Teja, he has done some books of AoPS.
I have done your pre-algebra books. Or pre-algebra and the introduction and intermediate series. And I really like the entire method you follow. Like, first giving the problems, you give us an opportunity to, most of the times we get to prove the formulas or whatever on our own. You sort of divide the problems into bits. And I also like how the books progress, because like it's very continuous. I've been doing them since 5th grade, so they've helped a lot. Yeah, thank you.
It's awesome. Thank you.
Thank you.
Sri Teja has been in our program since the last 3 years, and he's in the advanced group right now. And,
awesome.
Yes, and there's one more, Manu, who has been doing since a long time. He was there in Epsilon for 4 years, Epsilon US. Manu, would you like to share your experience? I've put you on mute, and then maybe I'll just leave it to you for taking questions if it's not very late for you. Just one second. Manu? Yes, Manu.
Yes. Okay. So I've been doing AoPS for about 2 years so far. I really like the courses a lot, and I've done 2 courses, the geometry course and the intermediate algebra course. They both were hard, but I got through them, which I liked.
That's good. I think that the courses should be hard, right? If you're a new course that's not hard, it's probably not the right course for you, right? You want to be challenged, and that's your learning. So that's great.
That's right.
That's fantastic.
Thank you, Manu. Okay,
So
how would you like to take? Sorry. Yes, Manu. I'm sorry. Sorry.
I also do a lot of alchemist on my free time when I'm not working on course material or I don't have a course going on.
Awesome, yeah.
Which I really like a lot.
We're doing some.
I definitely recommend Alchemist to anyone here. It's a free tool. Anyone can join up. It gives you a great little taste of art of problem solving. If you don't want to, commit to registering for a class or something, Alchemist is fantastic, and you can learn a ton from it. So.
And was Math Jam part of AoPS?
Yes, and I did some of them.
Yeah, so Math Jams are basically our free classes, essentially, free that we run that are sort of one-off sessions. We actually are running those right now on Wednesdays and Fridays at 10 Pacific time. So that'd be an hour and a half from right now in terms of time, but not today, tomorrow and Friday. So if people are interested in those, in general, 10 a.m. Pacific time, we've been running this. Actually, this week we don't because it's math counts this week. But if, for example, next week, Wednesday at 10 a.m. Pacific time, you're free, jump in and you can do a free class session, sort of like whatever I was doing here, or some interesting math.
Devin, could you answer the question that some of the students had about how you can join a class and then talk to them about the pre-test and the post-test and how you go about choosing a course?
Yeah, happy to. To join an Art of Problem Solving course, I guess I still have my screen shared. So let's go ahead and go to Art of Problem Solving, if I can spell it, .com. Let's see if this will ever load. Sorry about that. Okay, so if you go here to the online school, you can actually see our class schedule. You can see all of the classes that we're offering at any given time. So let me let this load so you can see we've got pre-algebra 1 at all these times. So these classes are coming up, May 14th, this one starts. You just enroll through that. These meet once a week on whatever sort of day they say. So for example, this pre-algebra 2 class is on Mondays. It started on February 24th, so you're probably not going to register for that. But it meets every Monday from 7:30 to 8:45 Eastern time. And so, for example, if you say, hey, somebody mentioned if we have calculus, we do. You could scroll on here. It's way in our advanced math category, but we do have calculus classes coming up. This one just started. This one starts next month. So those are coming up. You can find all of our classes here. And if you're kind of wondering, hey, what class is right for me? Is Introduction to Algebra B the right level for me? Then what you can do is you can go here and check, do these diagnostic tests. Am I ready for this? Do I need this, right? So if I just crush this, do I need this? Then probably this class, probably don't need it. I can skip ahead to the more difficult one after, so I can skip that one. So these basically give you a sense of, hey,
sorry,
I'll do this.
Can you just explain that part again? Are you ready,
Yeah.
and do you need what's the difference?
Yeah, so are you ready is to determine, do you have the prerequisite material to take this class? So do you know the stuff leading up to this class, or should you go down a notch from this? So this is to kind of decide where you should end up. Do you need this is the other side. So you can imagine the class fits right in between are you ready and do you need this? So if you've done the class, you should be at passing, do you need this? And if you don't need the class, then passing, do you need this? And if you pass, are you ready? You're ready to take the class.
Thanks. Okay.
Okay, yeah, does anyone have any other? Don't get, do you need this? Okay, so do you need this is basically, can I skip this class? Yes or no? Have I already learned this material? So if you do take that test and you do very well, that means you already know that material. You don't need to take that class. If you take that class and you don't do particularly well and do you need this, then you probably should take this class. Okay. Does anybody else have any other questions about art of problem solving? Can you change the squares problem to an algebraic one? You certainly can. Yeah, that is definitely possible. It's definitely possible to make that an algebraic problem, which I think is interesting. And people are asking for emails. If you want to email to Art of Problem Solving, you should email info@artofproblemsolving.com.
Yeah, I apologize. I can hear everybody. I can hear what's going on, but my screen froze and I was too scared to shut it down because I'd be kicked out of the meeting. So I couldn't see the questions if there were any other questions in there. But yeah, Devin's right. Email us at info@artofproblemsolving.com and we'll get back to you with whatever you need.
And yeah, somebody's saying writing squares as the sums of other squares. Yeah, that's definitely something. You can try to turn that into an algebraic problem. I think that's really interesting. It's an interesting fact that you can do lots of stuff. So yeah, will it cost us? Yeah, these classes do cost money. Alchemist is free. The classes range in price. You can see this Algebra B class here is $405. Pre-Algebra 1, let me see if I can jump to that. See if I can find it here. Is $370. So yeah, you definitely need to, the courses do have price, and you pay for them. Alchemist is free, a free resource that you can jump into anytime you want. So I can jump over there and say, okay, Alchemist.
And apart from the online classes, there are books as well, right? Books and self-paced courses. So there are a lot of other. So it's not necessary that one has to join the class if the time.
That's
is
right.
too
It's not necessary to use the class to do art of problem solving or have art of problem solving material. You can go through our books. We have books for all of our subjects. You can go through Alchemist. I've known a lot of people who learn through the books and Alchemist combined. Kind of you're using the books as your, guide, and Alchemist as your homework essentially, or as your practice. So that's certainly possible. The forums here, somebody's asking. So I click here. Basically, the forums is just a big community of problem solvers, a big community of math nerds, I would say, are all on these forums. You can see, hey, in middle school math, high school math, people talk about all sorts of stuff. So that's kind of where we're at there. Will we get video classes of yours? There's actually something interesting that you could consider. I don't know if the time will be right for you or not, but this summer we will be offering some video classes for what we are calling our virtual academy so we're going to be doing some summer academy classes online through this, and so that's certainly a possibility. I did some books. That stuff might not be that hard. Like yeah, Counting and Probability. That's one of our books that we have, and I definitely recommend it. Take a look at it. It's fantastic. Yes, that stuff is paid. The academy is paid.
Okay, so I think those who are asking about the cost and other things, maybe timings and things like that, I would suggest you visit the website, because all those things are there. If there are any other questions which you cannot get from the website, you feel you can ask Devin, and he'll be happy.
Yeah, there's an interesting question here. Do we teach concepts from scratch? Yes, we do. All of our courses are sort of fully contained. We intend to have you figure it out from not knowing the material beforehand. Of course, we're going to have to assume something. We're not going to teach the basics of 2 + 2 in our intermediate algebra class or something. So that's what these sort of pre-tests are for. Make sure you've got the basics down that we're going to assume, but from there we're going to teach from scratch. Shoot, these messages are popping up. I've somehow scrolled up and lost them.
Okay, so can I just read them for you? One is, can you do an intermediate book on intermediate geometry?
That's something that's on our minds. We're not currently working on it, but yeah, lots and lots of people have asked for that. So it's on our minds. We do teach programming. I see another question there. Yeah, we teach classes for Python, actually. So just fitting along with a regular sequence, but in Python.
Somebody's asking for
RMO contest.
Regional,
so yeah, I would definitely
mathematics Olympiad.
Yeah, I would definitely recommend our Woot course for that. So Woot is our online Olympiad training course. It's totally good for any Olympiad. It's not specifically geared to, let's say, the US Olympiads. It's definitely useful for all over the world there. I'm taking intermediate number theory with Achilles. That's fantastic. Achilles is a great teacher. I'm glad to hear that. And thank you for whoever just linked Woot there. That is definitely the place to go if you're looking for Olympiad training. Can we ask questions on the website? Yeah. So if you have questions, do you mean in a class, or do you mean like you have more questions later from this session? I'm going to answer both, I guess. If you have more questions from this session, generally I would recommend emailing us at info@artofproblemsolving.com. If you want to ask questions during class, if you're taking a class, or just ask questions about math, yeah, you can totally do that. So during our math classes, every class has their own individual message board that we're monitoring sort of all the time, and are specifically available from 4:30 to 5:30 Pacific every day to answer your questions and sort of chat back and forth with you. But yeah, you can ask questions at any time. We'll answer them there if you're in class. If you're not in the class and want to ask a math question, I recommend going over here and figuring out which category it's in and throwing it in, and people will discuss with you. I think a lot of the interesting things is here. For example, if I just pull this up, this is just, some student posted this question and they're discussing it together, a bunch of different students. And I think that's really interesting and an interesting feature of art of problem solving. Yes, after classes, you are expected to do some work on your own. So we give you some specific homework that we want you to do, some specific reading from the book, and oftentimes some specific lessons we want you to do in Alchemist.
Okay. Okay. So shall we take a pause here, or if you have anything like a final thing which you would want to share with the students?
Looks like people are requesting our email again, so I'm just going to type it into the chat so people.
Yeah, I apologize. I can't see what's
go.
going on in the chat right now. I can only hear what's going on.
Oh shoot! I just sent that to somebody privately. I meant to type everyone. Everyone. There we go. Okay, there you go. Okay, so that's the email you can email us if you have any extra questions. Okay, yeah, thank you guys so much.
Okay.
I had a fantastic time with all of you.
Yeah, thank you to everyone. Thank you to Vinay and Chitu again, and to all the students. Thank you so much for spending some time with us. We had a wonderful time. We hope that you go to Art of Problem Solving and just play around. Check out Alchemist, check out the community. There's lots of fun stuff in there. We've written a ton of articles that you might find interesting, tons of videos. Basically, if you just go to artofproblemsolving.com, and in the upper right-hand corner, there's a resources tab. All the stuff in there is free. You could just get lost in there for days and spend tons of time. So I encourage you all to do that. And please feel free to reach out. If you have any other questions, we're happy to help.
Okay, so let me just take this opportunity to thank both of you, Devin and Grayson. Honestly, I never felt that you guys were away from us. It was as if we are having a face-to-face session. So and as you could see, the students also have got so engaged, and I can see a lot of them saying that it was a short session. So probably for our next camp, we can have a longer session. Maybe we can we can do something for a longer duration.
Definitely.
So thank you.
Yeah.
We'd be happy to come back. Yeah.
I'm happy to write some more problems. I didn't know what the right length was.
Yeah. So thank you so much, Devin. I mean, I could see how much of passion and effort that you put into go through all these chats. I wasn't able to follow on each and every message, but you are doing it effortlessly. So thank you so much. And Grayson, it's been great, Grayson, interacting with you since last few months. And thank you so much for taking this time out and addressing our students. Thank you so much. And to the students, I just want to say why we thought of having this particular session is mainly after we started seeing some of our students who benefited a lot by taking courses on AoPS, and we felt that many of the resources of AoPS would be very valuable for you. So instead of we telling you just go and check out the website and things like that, we felt it will be better if we have an interactive session where you can get a first-hand experience of how it is to be in a AoPS class. So that's what we thought, and we sincerely thank Devin and Grayson for spending that valuable time with us. Thank you so much. We'll keep in touch.
Sounds good.
Awesome. Have a great rest of your day, everybody, and thank you so much for doing some math with me. I really enjoyed it.
Thanks, Devin. Thanks, Grayson.
All right.
Thank you so much. You have a nice day. Yeah. Yes. Thank you. Bye-bye.
Okay. Bye-bye.
Would you like to see our participants? We can just ask them to switch on the video. I mean, I'm sure they would be happy to,
sure, go
so
for it.
You'll have to stop sharing.
Oh, yeah, sorry.
Yeah.
Let me see if I can figure out how to do that. Yeah. Stop share. There we go.
So they all
Hi, everyone.
Yeah.
And there really are a ton of you in this meeting. I'm impressed. You got a
great
huge
participation.
turnout. Yeah.
Fantastic.
So it's 9:15 at the night, and I'm sure these guys will go on, but I'm just a little concerned about tomorrow early morning session. Otherwise, they won't leave you, Devan. I'm sure about that.
That's great. Thank you guys so much. I had a fantastic time. It's great seeing all of you.
Thank you, everyone.
Thank you so much.
Have a
Bye-bye.
great evening.
You too have a great day. Bye-bye, Grayson.
Bye.
Bye, Devan.
Bye.
Bye.